at the corners of the object or particle.
Okay. Suppose there is some obstacle like that, or a light ray is traveling in a rectilinear path, but when it's tried to pass just edge of an obstacle, it bends in geometrical shadow. Okay, it bends when it passes very close to a edge of an obstacle. That phenomena is known as actually diffraction. Okay, in our laboratory, how we do that? We actually we actually use that single slit, double slit like that. Okay, so you can experiment it with a single slit also now. Okay, so you could just to take a slit. This is a slit from which the light can pass. You have a source here. This is the source. Okay, fine. This is the source. The light will pass through. Okay, it will pass through, and when it passes the edge of an obstacle, it will bend somewhere like this. It bends, and it may bend this way also, and after that you can see that some portion of in a screen, that light rays superimpose to each other, and they meet either meet same phases, different phases like that. So it produces some pattern, bright and dark, consecutive bright and dark pattern. Okay, and that pattern is very specific for a single slit. This pattern is something defined from interference pattern. Okay, we shall discuss what are the differences between interference pattern and diffraction pattern. Before that, let us discuss the types of diffraction. Okay, there are two types of diffraction. Types of diffraction. Two types diffraction are. One is Fringes diffraction, another is Chronopod deflection. So first one is Fringes diffraction, and second one is Chronopod deflection. Okay, two types. Now, in case of Fresnel diffraction, you have a slit, fine, but source and screen. You need a screen to visualize that pattern, bright and dark pattern, and you need a source of light. If source of light and and screen and source both are at finite distances, both are at physically finite distances from the, the slit, then it is known as Fresnel diffraction. That means the wavefront that is incident on a screen is not a parallel, it's not a plane wavefront. This wavefront, it may be like this. Okay, do you know what is wavefront?
Yes, sir.
Okay, so in that case, as the source is at finite distances, the wavefront that incident on a screen is not a it will not be a plane wavefront. It is a curved wavefront, and the after passing through the slit, it will also not be the wavefront must have some curvature. Okay, so this is Fresnel's diffraction. And in case of Chronopod diffraction, you have a slit, but source and screen are at infinite distances. What will happen? Source and screen are at very far distances. Very far means that the incident lights, or you can say incident wavefront, are parallel. Sorry, incident wavefront are plane wavefront. Okay, light rays are, you can say light rays are parallel. Wavefronts are parallel wavefronts. So that you can say that your source is at infinite distances. Similarly, the light passing through out must have plane wavefront when it incident on a screen. Okay, so how you can do that in our lab? How you can place a source and screen at infinite distances? It is not physically possible. So we can arrange something so that it appears to be possible. It, it is possible, but you must have arrangement for that. Okay, so this is known as Chronopod diffraction, when source and screen are at infinite distances from the slit, and for Fresnel's diffraction, source and screen are at finite distances from the screen. In our syllabus, we actually briefly discuss Chronopod diffraction. Okay,
Yes, yes, sir.
so in case of Chronopod diffraction, in case of Chronopod diffraction, we'll study single slit, sorry, single slit experiment. We'll study double slit experiment. We'll study grating, grating with grating experiment, diffraction in grating experiment. I think you did the experiment, although in online form, you did the experiment in grating experiment with laser.
Yes,
Can
sir.
you remember?
Yes, sir.
So we'll study all of this, and we'll start it from single slit experiment. Before going to that, okay, there are some differences between interference and diffraction. What are the difference between interference and diffraction? Interference En and diffraction. Okay. Interference occurs when two separate wavefront originating from two coherent sources. Okay. Interference occurs when two waves interfere, means they superimpose to each other at some point, but they must come from two different wavefront. That is why we use double slit experiments. So one wave is coming from one slit, another wave is coming from another slit. So you have two separate wavefront. From there, two waves are coming and they interfere. Then interference will occur. Is that clear?
Yes, sir.
But in case of diffraction, it is happens that you have a same wavefront. You have a single slit, say. So this is a single slit. So this is the incident wavefront, and at defined part of the wavefront, defined waves are coming from, suppose from at this point, from this part of the wavefront a wave is coming, from this part of wavefront another wave is coming, and they interfere at some position. So waves may come from same wavefront but at different position of the wavefront, and they interfere at some position. So it will produce diffraction pattern. Clear or not?
Clear, sir.
Secondly, fringes, I mean dark and bright fringes, may or may not be equispaced or equally spaced. Okay. Generally, they are equally spaced in double slit experiments. Okay. But in case of diffraction, fringes they never equally spaced. Okay. Clear? So in us on a screen, so you have a consecutive bright and dark fringes, but that fringes are equally spaced. Here about it may happen they are equally spaced, but here that bright and dark fringes are never equally spaced. In central region, you'll see maybe they are nearby, and far away from the central fringe, separation between bright and dark fringes may increase. Okay, clear? Hello,
Yes, sir. Yes, sir.
कौन मैसेज कर रहा है? Okay, and what about intensity of the fringes? Intensity are equal. Intensity are equal for all. Sorry, for all fringes, but here intensities are different. Okay, intensities are defined here. Can I remove all this?
Yes, sir.
Okay. Now we shall learn one by one. First of all, single slit diffraction pattern. Single slit diffraction experiment. अमोल कुमार चक्रवर्ती उसमें मतलब ड्राइंग भी अच्छा था, वो बुक में अच्छा था. नहीं है, इसका नोट भी था, इसका नोट भी था, थोड़ा सा देखेंगे है कि नहीं मेरे पास। जस्ट रुको थोड़ा सा। BS-PH201 starting to रेटिंग का एक है, बट ये जस्ट मिनट। ओके छोड़ो नहीं। ओके, so single slit diffraction pattern. And this is the big slit. This is the slit. Fine. Light rays are passing. Okay. Let us give it some arrows. So these are parallel light rays. This is the middle point. So in our lab, how you can get a parallel, parallel light rays? So you can use a lens here. We can use a lens here also. We have to use a lens here also. Okay, and let us draw another line on the middle, and समझ में आ रहा है? So, so this is
Yes,
the
sir.
source.
सर वो सोर्स फोकस पे है सर.
फोकस पे है, राइट. सो ये सोर्स फोकस पे है, तो रे after refraction through the lens will be parallel. So the incident wavefront is now parallel. Incident wavefront is now parallel. It's parallel wavefront, and right. Incident wavefront is now parallel, and after refraction also, if there is no diffraction, they will meet some point on a screen. Fine. If there is no refraction and the screen is at the focus of the second lens. This is L1, this is say L2. Now if there is diffraction at the edge of the slit, so diffracted ray, so this is the wavefront. After say light rays are diffracted at an angle theta. Theta is the diffraction angle, and they meet at some another point. Something about here. So says this is a central point, this is a P point, like that. So this is about the single slit diffraction experiment. Now if the light rays meet at obey some condition, then you can see some bright and dark spot on the screen. So that angle can be anything. So depending on that, they can meet here, 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 anywhere in the on the screen. Now total derivation is not required here.
Okay, sir.
तुम्हारे पास अमोल कुमार चक्रवर्ती का बुक है ना?
सर था, वापस कर दिए कॉलेज में.
क्यों वापस कर दिए? अब देखो इसमें भी अच्छे से नहीं है इस बुक में. ओके, थोड़ा सा रुको, मैं देखता हूँ कोई डॉक्यूमेंट हो सकता है. मेरे पास एक बुक तो होना चाहिए था. ओके, थोड़ा सा करता हूँ, ट्राई करता हूँ, ठीक है। इंटेंसिटी राइट डाउन, इंटेंसिटी ऑन द स्क्रीन, intensity at the screen, ठीक है। this is the general formula. Intensity at the any point on the screen is I equals to I0 sin square alpha divided by alpha square. Let me see it. Sin square alpha by alpha square. Okay.
So alpha is the angle of diffraction.
Just a minute. Just a minute. Where I0 equals to Ka, I think K square. It's actually square of amplitude. Okay. Intensity is actually square of amplitude. The maximum intensity for alpha equals to 0. This is the maximum intensity for alpha equals to 0. What is then K? K is the amplitude of the incident light wave. K is amplitude of incident light wave. Small a is the slit width. What is small a? Is the slit width. Slit width means from this position to that position. That width is A. Fine. Next, alpha. What is alpha? Alpha equals to pi a sin theta by lambda. Here theta is the diffraction angle. Now everything is defined. Now alpha, what is alpha? No, sorry, lambda is the wavelength of light. तो इसको याद रखना पड़ेगा, टोटल लिख लो, अच्छे से नहीं है बुक में।
Yes, sir. Okay.
Okay. The problem is we have to find the condition for maxima and condition for minima. ये भी तो अच्छे से नहीं है बुक में, बहुत कॉम्प्लेक्स तरीके से है। Okay, yeah.